For the PCI Big Beam competition this year, the University of Notre Dame had 2 teams. I led team number 2, which was comprised of 8 students, 4 seniors and 4 juniors. The seniors were primarily responsible for the beam design, while the juniors were responsible for the concrete mix design and the beam fabrication. This allowed each student to best contribute with the education that we each had. However, because none of us had taken any kind of precast, prestressed design course before, we all took a 1-credit course taught by Dr. Karama, in which we were given the fundamentals necessary in order to best compete in the competition. In order to get to testing day, which is the point we all are reaching for, we went through 6 different steps. The first of those was the beam design, in which the seniors got together to do the allowable stress design, the ultimate strength design, and the shear design, all the while trying for the most efficient and economical beam possible. Concurrently with the beam design, the juniors were busy working on the concrete mix design, in which their goal was to reach the highest strength possible in order to provide the smallest cross-sectional area. In order to do this, we actually had to bring in granite from Wisconsin, because it gave us a higher aggregate strength than the limestone that is locally available. Once the concrete mix design and the beam design were completed, the formwork and rebar construction could be done. This was a great experience for everyone to get hands-on and bend the rebar, cut the wood, and build the formwork. Once the beam was ready to go, we then went over to our PCI producer member, Stress Core, located in South Bend, Indiana. There we pre-stressed and cast the beam. 3 days later, we transferred the pre-stressed load and then allowed the beam to cure so that the concrete could get to its max strength. During this time, we completed the pre-test calculations in order to prepare for testing day.
So testing day. Testing was on a Friday morning, February 10th, very, very early in the morning. And you're a bundle of nerves when you show up for testing day, because you've been working on this project for 6 months now, and it's all this effort and time and energy that you've put into this project, and you're so invested in it. And this is the moment of truth. This is where you see if your design actually works, if all those assumptions are correct, if all that work is going to hold up to everything. So it's really nerve-wracking to show up for this test day. But we set up our test beam. It was a simply supported beam. We used a spreader beam to get our 2-point loads 4 feet apart on center. And then we started to incrementally load the beam. We would load it to designated point loads. And then we'd try to get up, or we were loading it up to the cracking load. And so the limit for this competition was 20 kips. So once you started getting up there on the loads, it would be about 18 kips. You're sitting there going, come on, you can make it to that 20 kip load. And luckily our cracking load was 20.5 kips. So we were really happy with the way that the beam performed in that aspect. And that was the first hurdle to get over. It was kind of halfway there, so to speak. But once you hit that cracking load, the beam would start to crack. So at each designated load point, you'd stop and you'd mark the progression of the cracks with a paintbrush style, map out what was happening with the beam. And it was good to see that all of our cracks were flexure cracks, and there weren't any shear cracks on our beam, which meant that our shear design for this beam was working the way it was supposed to, and it was actually a good design for the beam. So that was really reassuring to see, as the beam progressed. It was a good pat on the back. And then there became a point where the deflection became so big per unit of force applied that we actually stopped loading the beam per increment of load, and we did it by half-inch deflection increments. And so that was also kind of a surreal moment when you're watching this beam. You built the beam, it's out of concrete, there's a lot of steel in it, you know exactly what's in the beam and how it was made, and a sturdy beam, and you're seeing it start to bend and bow and have this parabolic shape. It's not straight anymore, and you're looking at it, and you're really happy that it's deflecting, because that's the way it's designed. You want a beam that deflects, that's good, but you're also looking at it going, but that kind of looks unnatural. That's not a way a beam's supposed to look. So it's really interesting to see the actual testing process of the beam and how it performs under extreme loads. So that was really cool. But our beam actually, when it failed, it was a failure flexure, which was the failure mode that we wanted. So we were really happy with that too. And we had our ultimate load of 33 kips and maximum deflection of 6 inches. So again, we were really happy with that because it passed the serviceability and factored limits for our cracking load and our ultimate load. So we were really happy with the way that our beam performed on test day. The reason I was really interested in this course to begin with is because it was the first time I would actually be able to create something. In classes up to this point, you get a lot of theory, you don't actually get to build it yourself, and so this time it'd be, you turn your own ideas into something that is real and tangible. And I think that's why most people go into engineering, especially civil engineering, is they don't want to learn about what already is, what other people have done. They want to turn their ideas into real things and turn their thoughts and make something tangible themselves.
It's just been a great experience for me these past 2 years. Last year being responsible for the rebar cage construction, and this year basically leading the team and coordinating all the different facets of it. So I really am grateful for the chance to kind of put my leadership skills to the test, and also the education that I've learned the past 4 years to really see what I'm made of, and it's been a great experience.